Okay, so now we are moving on and we're going to do the same thing we did yesterday, but now with two means. So we're taking two samples from two populations and comparing them. Lucky for us, we already did this with percents, so we have some foundational knowledge we're building off of. So when we do a significance test for a difference in two means, we are looking at mu1 minus mu2. All right, so we're looking to estimate or make some statement about the difference in the two population means. Our null hypothesis always says that they are equal to 0, that difference is 0, whereas our alternate hypothesis says that difference could be greater than 0 if the first mean is bigger, mu1 is larger. Could be less than 0 if mu1 is smaller. Or it could be not equal to 0, which just proves they are unequal. All right. To run our test of significance, we find that t-score like we did yesterday. That t-score formula is this guy right here, which is emphasized here, right? And on our formula sheet. So remember, on our formula sheet, all it gives us, is the standardized test statistic, like general formula, similar to confidence intervals, right? And then we know our standard error always comes from the far right column, either for percents. Today we're in means. We have two means, so it's S1 squared over N1 plus S2 squared over N2, and we take the square root of that. All right, so researchers are interested in studying the effect of calcium on blood pressure. They take a random sample of 60 healthy 20-year-old men and randomly split them into two groups. One group received a calcium supplement for 12 weeks, and the other group received a placebo pill for 12 weeks. In the end, they measured the blood pressure in milliliters of mercury, and they found the following. Okay, so group 1 had a sample mean of 2 with a standard deviation of 0.83. Group 2 had a sample mean of 3.2 and a standard deviation of 0.9. Okay, so now we're going to run our test of significance. So we are looking at the difference in the mean. Blood pressure for each group. Okay, and we are using the alpha level 0.05. We are going to say our null hypothesis, always for two samples, is equal to 0, where our alternate, HA will be that difference. Let's see here. So, run a test of significance to see if the calcium helped lower blood pressure. Remember, group 1 is calcium. So here this means that mu1, the mean for the calcium group, is less than mu2. So when we subtract them, we get a negative value. All right, we did take a random sample of absolutely less than 10% of the population. Right, our sample was 60, so 30 and 30 is definitely less than 10% of all healthy 20-year-olds. All right, and then normal is true because N1, our sample for the first group, is greater than or equal to 30. And N2, our sample for the second group, is also greater than or equal to 30. Okay, so now we calculate that t-score. T equals the difference in our two means, so 2 minus 3.2 minus the claimed value for that difference, which is 0, over the square root of our sample, standard deviation squared, so 0.83, 0.32. Okay, so we'll get negative 1.2 up top, and then 3 squared over 30. I got negative 5.368, so 37. On our curve, that'll be way, way down here. Our null hypothesis said that the difference was negative, so we shade to the left. So this will be TCDF, where we go from negative 1,000 to negative 5.32 with 59 degrees of freedom. Right, if we look up here, oh, whoops, nope, it says, use the t-distribution with degrees of freedom approximated by technology. We're not going to do that because we don't have a way to do that. Or the smaller of n1 minus 1 and n1, n2 minus 1. So whichever of those is smaller. Well, in this case, our sample size is the same. They're both 30, so we actually are going to say we have 29 degrees of freedom. Which makes sense because technically we don't have a sample of 60. We have two samples of 30. So we would use 29. Okay, so that is a tiny, tiny number, 0.00000. I get 5.21 times 10 to the negative 6th. So 521, which is less than any level of significance we could have. In this case, it was 0.05. So that allows us to reject the null in favor of the, well, let's just say HA. Proving that mu1 minus mu2 is negative. Now the question asked, did calcium help lower blood pressure? Blood pressure. And we can say yes, calcium did help lower blood pressure. All right, now let me see here. Okay, so in the practice, I do have you do a confidence interval, so we are going to do one just as good practice. So remember, you take the difference between your sample means. So you'll do 2 minus 3.2 plus or minus our t-score. Here, I'll write my inverse t with 0.025 because it's a 95% confidence interval. And 29 is my degrees of freedom. 2.05 times the square root of my two sample standard deviations. This is the exact same as it was before. So if you already have it, I do not, but if you do, that'll help you. So this is negative 1.2 plus or minus. I'll calculate that margin of error, 2.05 times the square root of 0.83 squared over 30 plus 0.9 squared over 30 is 0.4582. negative 1.658, so we could say 6, to negative 0.74. And our units here were milliliters. All right, and so because we rejected the null in favor of the alternate, we said that the difference in the two population means is negative. It's less than 0, which means that this first mean is always less than the second. And this tells us less by that much. So if we take the mean for the first group, all the people in the first group, and the mean in the second group, and we subtract them, calcium makes that big of a difference on the average blood pressure. Okay, so we will talk to you tomorrow.